Siom is the co-author and discoverer of the early Homo jawbone in Ledi Era, Afar. Dr. Siom's other research interests include collection, preparation, and organization of comparative anatomy in Ethiopia. Currently, he's running his own project at the Kibish site in southern Ethiopia. In general, Dr. Siom is interested in understanding the diversification, morphological, and dietary adaptations in mid-Pliocene hominins and the origin and evolution of the genus Homo. Today, he will be presenting on Africa in the Pleistocene. Please give a warm welcome to Dr. Siom as he gives us his presentation.
Okay, I'm very happy to be here in the hub, in African Hub, having African topic, African in the Pleistocene, and I'll also thank you for the organizers for having me here and giving me a warm introduction. Today, I am going to talk about the emergence of early Homo. But beforehand, I would like to give a background about the hominin evolution in Africa. As many of you know, the term Africa is the cradle of human being, which is true, and Africa gave us invaluable amount of fossil hominin to understand humanity. So it is worth to talk about a little bit in general how we, how much we are getting from Africa in terms of understanding. First, I would like to just show you some of the major hominin sites in Africa. As you can see here, the record of early African hominin is coming from two main areas in the Eastern Africa and Southern Africa, but around in the 1990s, also found glimpse of hominin record in the Central Africa. This shows means evolved outside the rift system as well. So still, just two hominin species in the Chad and South Africa. All right, so it will be fair to talk about the background of the East and South Africa in terms of their depositional system before we talk about the fossils. So East Africa rift system is a result of fragmentation of a once stable continental lithosphere, and the East African dome started to enlarge around 40 million years ago, and this reached up to the elevation of 1 kilometer, and in the early Oligocene time, then it reached its peak up to 3.5 kilometer. As a result of tectonic activities along the margin of India, in the Indian plate and the African plate, there was a thinning of crust and graben formation. As you can see here, the Aegistine, the graben are forming, domes. So it started thinning down here. Then it forms the graben and the horst, so the valley and the ridge in the region is this creating, changing the environment in the landscape in East Africa. So one is widespread closed woodland environment disappeared in East Africa as a result of this rift system, changing the formation of the new landscape in the region. So the climate, was continuously changing as a result of this tectonic activity, and mountains were forming, and rifts were forming. And so the change pattern, this change, the air, the mountains block the airflow and affected the environment in the other side of the region, and causing the region to turn into a little more cooler and drier environment as time goes down over time. Yes, okay, this is just a schematic diagram just showing how the depositional system took place in East Africa. So the magma continues to form in Africa, and it flows, and also lakes and new river formation in the region were very common. All sorts of sedimentation took place, including conglomerate, sandstone, silt, and clay. What we see in East Africa today are as a result of this process in the rift system. So in East Africa, there fossils were preserved in a sedimentary basin. As you can see here, it's river. So when animals die, immediately they bury into the sediment, and also this because of a number of volcanic activity, there was eruption, and this creates ash, and they form along with the sediment, and they just give us the opportunity to date these sediments using argon-argon or argon-potassium method today to understand the age of fossils in these regions. So as you can see here, so this is what it looks like today, and this is one of the sediment in Hadar in Ethiopia. Since the fossils were preserved in lake and river sediment in East Africa, and lots of sediment are exposed due to the continued rift system even after the deposition. So interpreting and reconstructing of the stratigraphic layer of these sediments in East Africa is fairly, compared to South Africa, straightforward. And sediments are deeper. Sedimentous generally are older, and while sedimentous are higher, are younger. Again, so these ashes which erupted from this volcanic eruption just gave us the chance to well date the fossil deposits in Eastern Africa. Okay, all right. And okay, so now this is South African sedimentation and the stratigraphy. In South Africa, completely different, situation. And first of all, the South Africa is not in the Rift Valley system. So, we don't have, volcanic ash to date the sediments. As a result, and our datings, therefore, are imprecise and inaccurate, and usually we make a range of estimate. But now we, some techniques are developed to date better of these fossils, but still that remains a challenge. And most of our dating are questionable as a result. And in contrast to the open depositional system in Eastern Africa, mainly hydraulic, as I mentioned earlier, in South Africa, fossils accumulation are often on cone-shaped system in the caves. And so this is because the way the sediments and animal remains are washed into the caves. The accumulation process, as you can see, this is just like the caves, and this is one of the site. Look at how it is really very hard to tell, clearly the layers. It needs a very careful analysis. So how this happened was, in these sediments, we can see these cavities in the caves and underground cavities that had opening, which we already see them like this, to the surface already. And these cavities were produced by water dissolving a way more soluble rock, leaving holes between rocks that were more durable, and sediments and animal remains were washed into these cavities. And also, there are streams, and so these streams bring and deposit sediments and carcasses to these caverns, and the roof of the limestone collapses through time and enters into the cavernous. This is one of the cavernous, as you can see here, in a Storkfontein formed, and it's the most productive site in South Africa. And this was the caverns which has been accumulated sedimentous along with carcasses in millions of years and provided a lot of fossils. And as a result of this, we mostly use biostratigraphic dating techniques when it comes, we use in all sites whenever necessary, but mostly we use this technique in South Africa. So the dating accumulation in South Africa requires the use of stratigraphy because we don't have volcanic ash. So it involves comparing fossil mammals found in East Africa and which are well dated and present in South South the same time. So where the first and last appearance datum is well known. The dates in South Africa only estimates, most of them ranges for approximate average age of the deposit. So the reason we use pigs here, as you can see, very commonly used for biostratigraphic dating technique, is during the Pliocene, these taxa were highly diversified across Africa, and as you can see here on the tree, and the size and shape of their chewing teeth are very sensitive for changing environment. So they absorb these changes over time in their teeth, and which allows us to reconstruct the paleo environment. So their teeth is very helpful to reconstruct the paleo environment. So if we have, and so we can date that one. So we have this taxa well dated in East Africa, particularly in the Omo region. So we can use this biostratigraphic technique to reconstruct the age in Southern Africa. Okay, so this is just a general information about East and South Africa. And so everyone may ask, what are the major questions we are interested in our study in paleoanthropology? There are many, but I just listed some of them here. When and how and why did our lineage split from our sister taxa? chimp, gorilla, or orangutan. When and why did we start walking upright? When did we start using technology? When did we get large brain? Why is climate change a major factor for human evolution? And finally, here I have when and where did our genus Homo evolved? As you can see here, I highlighted one of the questions here I will be talking about, which I'm interested. I'm not here just to answer all these questions. These are really big questions. Hundreds of scientists are trying to answer. So I will try to just give my perspective of the genus Homo, given my one of the discovery in Lady Guerrero. So this is what it looks, the hominin species we believe to have this and related to us other than any other taxa, including chimps. So we call these hominins. They are our close relatives, as you can see here. There is a common ancestor between Pan and all hominin lineage here. Oh, it's hot here, sorry, I'm sweating. But we don't know exactly who the common ancestor was between chimp and hominins. DNA tells us the neighborhood of 7 to 6 million, but we don't have a fossil record to support that or and to have a better picture. So there are a group of people who are interested in studying the origin, or the, before the split between chimp and hominin lineage, older than 5 million years old. So this is a hominin record, generally in the Plioplastocene and generally grouped into 3 categories for my own purpose. In the early hominins, which includes Ardipithecus cadabra, Ardipithecus ramidus, and Ornithogenesis. And these are range in time between 6 and 4 million years ago, and were found in a range of environment from closed wooded environment to open habitat in Africa. We don't have them anywhere else. They are only in Africa, with the whole suite of new adaptation with distinguishing features that separates them from the chimps, while these extant apes are hanging on the tropical forest both in Africa and Asia. The second group here, or category or segments here, is the time 4 and 2 million years appears to have been anagenetic lineage, including at least Australopithecus anamensis and Australopithecus afarensis. And in this segment, we see more one major event, an adaptation to the changing environment in the major division, the hominin tree, that is a Paranthropus group here, extremely specialized group on the one hand, and the early representative of the genus Homo on the other hand. And these are our direct ancestors, but the time between 3 and 2 million years is poorly represented in this tree. As you can see here, there are questions around this area. I accept few taxa, Australopithecus, no, Paranthropus, Australopithecus, Hans and Garhi, and which there is a big question how they are related to the genus Homo. More specimens to at least answers for this. So the third segment, as you can see here, is includes all the species. Most of them are genus species in the genus Homo, and there are other species who are not listed here. But so there are other new species which are not included on this tree, to ask what happened in the time period between 3 and 2 million, or especially between 3 and 2.5 million years ago. Because of this, so this is the time we believe the genus Homo evolved and appeared in the fossil record. So we suspect suspect more fossil Homo in this time period. Before that, so how much do we know about early Homo before the discovery of the hominin? The jawbone. Generally, we have two groups of early Homo. We call them Homo habilis and Homo rudolfensis, represented by this cranium. And they are really younger than 2 million years old. And it is hard to link them with older specimen, particularly with Australopithecus afarensis, because there are some missing time. And we have this Uraha in Malawi, and the other one is in Hadar, Ethiopia, and this one didn't. There is a huge gap between, and this is what younger than 2 million, including Homo erectus, both in Africa and Asia. So the question is, what happened before, time period between 3 and 2 million years ago, especially between 2.5 and 3 million years. Then, so this really initiated a group of people in a particular area north of Hadar, a site called Ledi Gararu. And Ledi Gararu, as you can see it here, it is sitting between Waransumile and Hadar, and Gona Tekiga, Waransumile have their own significant amount of fossil hominins in Ethiopia, in that our is but today, the focus is on Ledi from Arizona State University, including myself. We're interested on questions related to early Homo, because we have some idea that there is, sediment which is around between 2.5 and 3 million years ago. So I wasn't the person who started this project, but this project has been doing this for many years. And they started asking questions like, if there is sediment in somewhere in the Ledi Gararu, I will come back to these names, the Hadar in Busudima Formation in the Lower Awash Valley. And the other question they have been asking was if there is Australopithecus afarensis or younger than 2.9 million years ago. That is the time which we have so far in Africa, in Ethiopia and Tanzania. The other thing is just obviously we see change and we expect some sort of environmental change. Is there significant climatic change which drove them to change into something? So that's the other question which was considered. And also we were wondering if there is other kind of hominin in that particular area. So with this question, this project has been working in that area for more than 10 years. And it is very close to these sites I showed to you. And there is a good record of fossils after, older than 3 million years in Hadar, Dikika, Gona, and Woranso-Mille, which are, in a close proximity to the Ledi Gararu site. They have, lots of hominin fossils. But there is one caveat on this, on all of these sites, just they are missing one part of the sediment. There is pool preservation, which is dated between there was a gap between 2.95 and 2.7 million, which there was disconformity. That means there was no sedimentation took place during that time period, which means there is no fossilization. And so we don't find any fossil. So as you can see here, the Busudima Formation younger than 2.7 million, and here is 2.95 million, older than that. Okay. So we have good record of fossils younger than this and older than this, but something is missing here. That's what makes Ledi Gararu site interesting, because there was this sediment exposed in this area. Prior to in the previous years, other geologists have visited almost every part of Afar region, and so they have some idea, and they just suspect there is a little bit older sediment, and also just that missing sediment could be in the Ledi Gararu, and that is why Kay Reed initiated this project and has been working for many years. It's not simple just to do a research without finding hominin for more than 10 years, but they established this dating that they discovered the sediment and they established the dating. All right, so what happened was then you can see here. This is a missing time period. Just we have this sediment in Ledi Gararu, which dated between 2.8 to 2.5 million years. So that gives us the chance just to consider the potential sites or localities in Ledi Gararu. So the Hadar site, it has well-dated stratigraphic formation, the Hadar Formation and the Busudima. So this comes and falls in between, and the sediment, if we found fossil, will fill some of the gaps we have in that time. And so this is what the sediments look like. So now we confirm there is sediment which is dated roughly between 3 and 2.5 million years ago. Makes it very interesting. And as you can see here, we have logs just columns showing different sites, Hadar, Lady Gararu, Dikikaina. Because from that will answer some really important questions. So then, this is what the site, the sediment looks like where the Lady Joe was discovered, and this is one of, this is what it looks like in the Afar region. So these are the sediments. We go there and we make a survey every day as a group. We involve many scientists, local young scholars from Ethiopia, in finding fossils, giving us protection at the same time. So we do survey, and that's our daily routine we do in the field. In one of the day we were surveying, I was looking for fossil, like other days, to one of the hill, and I come across to one just shiny piece of a tooth just caught my eye as I was walking. So, and then, oh yeah, I saw it just before even I pick it, I saw just, it is really thick, enamel. So I immediately realized, I picked up, and when I look at just there was a fresh break. So I will show you in the next. So they were not together, and even you can see this one has more matrix in sediment than this one. So they were sitting apart, but it showed me like it was a fresh break, which means the other piece is somewhere around. So I spent few minutes, maybe 2. It didn't took me that long. I found the other piece, and when I put them together, they perfectly fit as they are one left jaw of hominin fossil. So I immediately realized, yeah, that's going to be really important, because we already know how old that sediment is. No matter what kind of species it is, it will be very interesting. When we look at the first time, we thought, hey, this is small, looks like Australopithecus afarensis, which we don't have representative older than 2.95, but we know this sediment is younger than 2.8. So, if that is the case, that would be very interesting. This will be a late surviving part of population of Australopithecus afarensis. So that may give us some interesting clue how it is related with the later Homo species. Yeah, then just everyone gathered, and we started, discussing, chatting, and enjoying everything. So you can see this is the first picture. I just took it, but unfortunately I had bad camera and it is blurred. We couldn't use it for anything. I feel bad every time. But then we do some seeding. It's not easy. Just when we go to the field, we don't go and grab and walk and just, okay, we found this jaw and this is what it is. But it requires a lot of things to do even in the field before we come to the lab to analyze the specimen. So we sieve and we do crawling and collecting any piece to see if any piece of those can fit to the jaw. And once we finish this one, we go to the lab and we start our analytical work. So this is what it looks like after it is cleaned. And so it's really beautiful, you can see, compared to the other one. So it's the same jaw, just different view. And it's the left side, as you can see. And so this paper, this fossil was described by a group of people, including myself, and it was published. 2 papers were published. the same year in 2015. We found the fossil 2013, but the paper was published in 2015. One is, which is about the geology, the dating, the environment, and the other one is specifically focusing on the jaw itself. So that was really very exciting time for everyone. And what make us just to decide, other than looking at, we thought it's a different species, and we decided this early Homo, because just we took it, we compared with different jaws we have in other, in Ethiopia, in Kenya, and South Africa, because most of the labs have some casts, of different hominin specimens here in the US, so it makes it easier to compare in some cases, but not always. So as you can see here, this is the afarensis, which is older, and this one is the Lady Gararu specimen. We call it LD 350-1, and so you can see this highlighted. It is just a contour which looks like a chimpanzee, more of a chimpanzee-like in Australopithecus afarensis, but in our jaw it is more a Homo-like, just a later Homo specimen we have. The other feature was, as you can see here, I wasn't putting that many specimens here, but I'm just comparing with afarensis one. But we all did, in actual analysis, we did with the later Homo, with Africanus and everything. Just we have to consider any scenario this specimen could be. Is it a female, male, or of one species, or is it the younger version of this, or the older version of that? So we have to, compare with everything, and mostly we did. And as you can see here, this is afarensis mandible, but in this parallel, very typical characteristic of later Homo specimen, like Homo erectus, Homo habilis, Homo rudolphus. So give us some idea what it is. So we also, did I miss something? Okay. We also did some, I think I will take you this. There's the posterior lateral Australopithecus afarensis has prognatic face, very protrusive face. As a result, the nerve is and blood vessels which come out from that foramen, mental foramen, they have space to go forward and just sit somewhere there. So it is opening anteriorly. In Homo, just most of the species in the Homo genus have more straighter face, but not exactly ours, but we can see we have straight face. That means retracted, there is no space, so it has to open backward and hide somewhere there. Otherwise, it will be hanging here and will be exposed for all kind of damage. So that is the cause, and so that is very typical characteristic of later Homo specimens, which fits well with the new lady specimen. So that, the other thing, you can see this ramus, the straight ramus standing is originating in Australopithecus afarensis at M2. This is, look at this one, Lady Gararu, the root of the ascending ramus is originating behind or at the middle of M3. Just, that's also another characteristic of the specimen. It falls with the Homo group instead of the Australopithecus. Wait, this, click something. All right, the other thing is just when we look at their dentition, the afarensis has bulged, molar. M2, this is bulged, which is they have ridge, and this one is more straight, and they have generally smaller teeth than the afarensis specimens. So the same thing, this is talking about the dentition. The only thing it involves Australopithecus africanus, and it's the same thing. It's different from Australopithecus and afarensis. And the same thing, this dentition, the width, the M2 and M3 not tapered in the back, as you hear in the lady specimen, in the upper wing posteriorly on the back side, but in the lady Gararo, they are more or less, even anterior and posterior width. The length, same thing. I will go to the next level. All right, so this is where, if you remember at the beginning, I questioned there is some missing, specimen. We still need more, but this is where the lady Gararo falls at 2.8 million years ago, and it gives us some idea what happened around that time period. That doesn't mean it will answer every question. Imagine it's just like a jaw. Then what comes is the environmental reconstruction. So now we know we have hominin, Homo, earliest Homo at 2.8 million years. The earliest, as I mentioned at the beginning, was 2.3 from Hadar, but this one is 2.8. It pushed it back by 400 years. And so what happened then? We should understand it, look at the environmental perspective as well. So some of the pictures and slides here, they are adapted from our paper and the presentation we use in different talks with Dr. Kimball and Kay Reed. So courtesy to them as well. So this is the paleo-environmental reconstruction. As you can see, here is more open habitat. This is closed habitat. And using abundance data, other faunal abundance data. So you can see this is a lady Gararo. This is also drier and wetter. Areas, better upper side of this image are dry, where the lady Gararo specimen falls. So it lived in, based on the faunal abundance, and we see a large number of taxa which are more grazers, which includes Al-Salafini and equids, very common, and they have the higher proportion in the fossil record during this time period. So this gives us, what kind of environment it lived. So this hominin specimen lived in open, dry environment in the Hadar, in the Afar, Lady Gararo. Then, so what does this discovery means for human evolution? So, like I mentioned earlier, the discovery pushed back the origin of the genus Homo by 400,000 years. It narrowed down the gap between primitive ape-like Australopithecus afarensis to human-like, more derived human-like Homo groups. The lady specimen dated 2.8 million years also had some primitive features which gave us some glimpse. It could give us some idea about the transition between these taxa. So therefore, this job on morphology that gives us the relationship between Homo and Australopithecus. So common question, so what's next? So the next thing we don't know what this individual looks like in a full scale. So we only have this jaw. So it will be great to find the, since we don't know it is brain size, it is body size, it is locomotion, which is, but usually we based on their postcranial specimen. So we need more of that, or something else which belongs to the same population will give idea to have a better understanding of the the evolutionary and adaptive package of the genus Homo at this time period. So genus Homo, the earliest one is, emerged, not just, don't take this like as granted. This can change tomorrow. If somebody finds something, it changes. That's what it makes this field very interesting. It is very dynamic. It keeps changing every time depending on we find some new fossils. Finding new fossil doesn't mean necessarily answer all questions. Even in some cases, it complicates even the existing question. So it's cool, interesting. So Africa is the cradle of human being, and it unites us as one people. And thank you very much.
All right, thank you so much for the presentation. I learned a lot of things that I myself didn't even know, so this is really wonderful. First and foremost, thank you for your patience. I know we've had some technical difficulties and we're trying to do our best to arrive at this new COVID era and make things work. We are going to make sure to provide this video on our YouTube channel as well so that it is accessible to everybody. I know it is just about 1 o'clock, and if you have questions, you can email us and we can share them as well, just to keep in time with our schedule. The other thing I would like to quickly mention is we are going to host a screening, the Five Blood, in conjunction with veterans here in the same place, November 12th at 6 p.m. and we'll share this information via email as well as Facebook. Focus on Africa will return February 3rd in 2021. Just like everybody else, we are excited to see what options we will have, certainly in person as well as virtually. For those of you who have a few more moments, we welcome you to stick around for a moment and we can use the chat features and we could take a couple of your questions. So I'm going to start sharing the screen and look at the chat so we can see if we have a couple more questions that we could take as well. All right, we have a lot of thank you here. All right, here's a question from Rachel. Since there are features both of earlier genera and the genus, I hope I'm pronouncing these correctly, and genus Homo, are there any surprises or any conclusions you see from this straw about which characteristics of Homo evolved before others? Thank you for your question, Rachel.
Okay, let me see. Okay, this question, okay.
Mm-hmm.
Yeah, you great question. So let me read the last part of the question. You are asking, are there any surprise or any conclusion you see from this show about which characteristic of Homo evolved before others? It is not possible to tell which one evolved first than the other one. So that would be a very interesting thing. You know, we have even major question: is this brain size evolved first, or technology using stone to evolve in the hominin lineage? These are even bigger question, and still we can't, you know, answer characteristic evolved before another one in using this job. But that seems interesting question. Yes, yeah. So in this taxa, yes, the M2 is the M2 is M2 is bigger than M3.
It doesn't matter about age or sex?
You know, if it is young, you know, it does. So we are making this inference assuming they are adult, and for sure it is an adult specimen, we know. So all these are grown up.
Can we say the gender, the sex?
Oh, no, we can't tell. Even we haven't assigned that specimen to a species level yet. We need more specimen. You know, we don't want to rush. It's hard. We need more of that type to give more detailed information, especially sex.
All right, thank you so much, everybody, for joining us today. We so appreciate your presence. Look out for the videos both on Facebook and YouTube. And we look forward to seeing you again next year, as well as our film screening next week.